Today I am going to discuss EOQ model, economic order quantity model with shortages. Previously, in my previous video, I discussed EOQ but without shortage. The difference is in this case we are going to consider shortages also. That means back orders are allowed in this model. Okay. Now the assumptions. What are the assumptions? First, as soon as the desired units of certain quantity arrive in inventory, the back orders are satisfied. That means the pending orders are to be satisfied first, only then the inventory will be formed. Next, production and replenishment is instantaneous. In the previous model, in the case of previous EOQ model also, I discussed this instantaneous means at the moment you are placing order, the materials are received. Next, C1 be the carrying cost per unit of time. This is the carrying or holding cost, same. Now, C2 be the shortage cost per unit of time. Again I am repeating, C2 be the shortage cost per unit of time. Next, CS is the setup or order cost. That is the cost required to set up the ordering system or order cost per run per order. If it is production, then it will be called as run, or otherwise it is order. Better it is order in this case. The total time period is 1 year. In this case, we are considering the problem for 1 year time period, which is divided into equal parts, say of interval time t, and t is equal to t1 plus t2. t is equal to t1 plus t2. ये t1 t2 क्या है? You can see with this graph. The total time period t. This is the starting point and this is the last point of the cycle. T is equal to, this is t. Time period t is equal to t1 plus t2. In this period, the inventory is being formed, and this period shortages are being accumulated. I think it is clear. For the whole period, equal number of time t. Again, I am repeating, this time t is divided into two parts, t1 and t2. During the part t1, the inventory is being accumulated. t1 is the size of the inventory for this part. And for time period t2, during t2, no inventory is available in the godown. The orders which are not being satisfied are being accumulated. When next time the Q quantity will be received first, this backlog order will be satisfied, and only then again the inventory will take the size. I think it is clear. So T is equal to T1 plus T2. During time interval T1, again I am repeating, the items are drawn from the inventory as needed, and during T2, orders for the item are being accumulated but not filled. That means shortages. Thus, inventory situation can also be described graphically with this graph. Graphically with this graph. I have just now discussed it. This is the total time period, and this is the time period during which the inventory is piling, stored in the godown, and this is the part where shortages are accumulated. And Q, the total Q, is the quantity which is being ordered. Okay. Now see few calculation. Now inventory over the time period T. The inventory over the time period T, which will be this part. Inventory over the time period T will be this area, because these are the shortage. These are not inventory. That's the area. Inventory over the time period T is equal to the area of the triangle. This area of the triangle. The base is T1 and height is Q1. Q1 is the size of the inventory. That's why inventory over this time is half into base into height Q1. That's area. Then what will be the average inventory at any time? Total cycle T, though average inventory will be, this is the total inventory divided by T. Next, annual inventory holding cost. That will be, this is the average inventory, that is inventory at any point of time, and C1 is the carrying cost or holding cost per unit of time. That's why for this cycle, for this period, in this case annual, the total inventory cost will be, holding cost will be this area divided by T into C1, because this is on an average the inventory quantity per unit time, always per unit time the inventory over the period, and C1 is the carrying or holding cost per unit of time. That's why this is the annual inventory holding cost. Okay. Now similarly, total amount of shortage, this is the shortage area over the time period T. First over the time period T, then we will consider the whole period. Will be half, this is the triangle also, half into base, half into T2 into height Q2. Q2 is the shortage size. Okay. I think up to this is clear. Now next, annual shortage cost. What will be the annual shortage cost? Annual shortage cost is equal to half into Q2 into T2, total area of the shortage divided by T, to find out the average, and it is multiplied by C2. C2 is the shortage cost per unit of time. Always on an average the shortage is this, and if you multiply this by C2, that is the shortage cost per unit of time, in this case 1 year, then the total shortage cost for the year will be this. Okay. Now annual cost. Now annual cost associated with runs or orders of the size Q. Runs equivalent to orders in this case, as it is an ordering quantity model, and this will be relevant for production case runs, but in this case we are using both the terms as similar. So what will be the ordering cost? Server का demand is D, and you are ordering Q units at a time. Q करके order place कर रहे हैं, तो how many numbers of orders? D by Q. This is N number of orders, और एक एक order का लिए cost है CS. So D is the demand for the entire period, means 1 year in this case. एक एक बार में Q करके order कर रहे हैं, that is the total number of orders for the year. एक order का cost है CS. C is the ordering cost per unit order, इसलिए total ordering cost will be this. Total ordering cost will be this. Q is equal to N into CS, the total ordering cost. I think it is clear. Next, from above we can write the total annual cost will be carrying cost, ordering cost, or order carrying cost plus ordering cost for the period plus shortage cost. These three type of costs are involved to get the total cost. If it is annual, then for annual all the costs have to be added. From above we can write TC, that is total cost, is equal to, this is for the holding cost or carrying cost, and this is for the shortage cost, and divided by T. T is a common term, that's why divided by T, and plus this is the ordering cost. That will be the total cost. Okay. Now, using the relationship from similar triangles, you see this triangle and this triangle is similar. This triangle and this triangle is similar. That's why we can write T1 by T. We can write T1 by T is equal to Q1 by Q. Q1 by Q. Q1 by Q from the properties of similar triangle. Again, this triangle and the whole triangle is also similar. That's why we can write T2 by T. T2 divided by T is equal to Q2. This is Q2 by Q. Okay. Q2 by Q. That is, we have T1 by T is equal to Q1 by Q, and T2 by T is equal to Q2 by Q. Now putting this value to this expression, we can write total cost. We can write total cost is equal to half into C1. This half into this is T1 by T. In place of T1 by T, we have written Q1 by Q. Already Q1 is there. That's why Q1 square by Q plus half into C2 Q minus Q1 whole square divided by Q. Why this? Because Q1 plus Q2 is equal to Q. You can see from the graph Q1 plus Q2 is equal to whole Q. That's why you can write in place of Q2 Q minus Q1. That we have written, because we have to convert to two variables Q and Q1, and plus CS d by Q already noted here. CS d by Q. I have already mentioned since Q2 is equal to Q minus Q1. Now, for determining the optimum values of Q1 and Q, what will be the optimum values of Q means ordering quantity, and this is the optimum size of the backlog order. You have to find out. You see, it is asked in the problem. What we have to do? As there are two variables, that's why we have to use the partial differentiation. The basic condition for optimization is total cost first with respect to Q1, which will be equal to 0, and another optimization delta TC delta Q with respect to Q will be 0. If you differentiate this function, total TC function with respect to Q1, and put it is equal to 0, and after simplification, I am not going to the mathematical process, it will take time. This is applied science, applied subject, that's why after simplification only the formula is being written here. So this is the, you can say this is the optimum shortage size Q1. This is the best, and this is the optimum ordering quantity. After putting is equal to 0 and simplifying, you will get this formula. So how it has come? It will take a lot of time to show the mathematical process. Only simplification is there, nothing else. it is not required for you in the exam. You just will apply this formula. And to prove it is definite minimum, the second derivative is also to be checked. If you differentiate this function again with respect to delta delta, then you will see that will be positive, greater than 0, and this is also second derivative is greater than 0. That means it is definite minimum that the cost will be minimum for this value of Q1 optimum value, Q0 optimum value. This is the ordering quantity and this is the optimum backlog size. Thus the optimum quantities are given by, these are the formula Q0. We have again written in a different way only, nothing else. 2dCs by C1, that is only after arranging, and C1 plus C2 divided by C2. If you take common, then you will get it C1 plus C2. This is the formula. And Q1 after simplification will come in this form. Q1 is this, C2 by C1 plus C2 whole Q0, and we put the value of Q as the optimum ordering quantity, then the formula will come this. Okay. Now another formula which is required to show here. This is the minimum annual cost equation. We have derived the formula for optimum ordering quantity and the optimum and best size of shortage, and this is the total minimum cost. This is the formula we have already derived. Total cost half C1 Q1 square. Only at the place of Q you will put Q0 optimum, which I have already calculated. For Q1 you will put Q1 0, that is the optimum quantity. Then you will get the minimum cost, and this cost will be the minimum. This cost will be the minimum. Okay, this cost will be the minimum. And if you simplify this, you can also use this formula directly. So what we have done till now, we have derived the formula for optimum ordering quantity Q0 and the optimum shortages size, that is Q10, for which the total cost will be minimum, and also the expression or formula for finding the total minimum cost. And you can also use this formula after derivation, simplification. You will get this formula, which I am not going to show you here, and it is not very complicated to keep it in your memory. So C2 C1 CASD and C2 by C1 plus C2, it can be easily memorized also. Now you have to check and use one practical problem. Now see the problem, how you solve it. In exam, this type of problem will be given. Inventory problem with shortage. Just I am reading this problem, and you can see in the monitor also video. A certain item needs to be provided at a steady rate of 200 units per day. That means demand 200 units per day. You can order any quantity of the item at any time, but each order incurs a fixed cost of ₹50. If you keep the item in stock, it costs ₹2 per unit per day as holding cost. You can say this is the holding cost or carrying cost, and this is the ordering cost, ₹50 per order. However, if there is any delay in supplying the item, you face a penalty of ₹10 per units per day for delay, and this is called shortage cost. That means shortage cost per unit per day is ₹10. Then what you have to do? You need to determine the optimal inventory policy. Yeah. First Q, how much to order each time, so that the inventory level after each order. And T, how often, कितना बाद में, to reorder the number of days between the orders. दो ऑर्डर के बीच में टाइम का गैप कितना होना चाहिए, how many days interval you will place the order. The questions are being made more clear here. What values of Q and T minimizes the total cost, including ordering, holding and shortage of penalty cost. और क्या, how would the best policy change? This is an extra problem. If the penalty cost becomes extremely high, say infinity, अगर ऐसा होता है, if the penalty cost are extremely high, that is infinity, if the situation like this, that means shortages are not allowed at all, तो कस्टमर कभी नहीं लौटेगा, इस तरह का बात है, बहुत कॉस्टली हो जाएगा, महंगा हो जाएगा. शॉर्टेज कॉस्ट इज ट्रेमेंडस हाई, infinity, meaning delays are not acceptable at all. तो रिवाइज्ड ऑर्डरिंग क्वांटिटी क्या हो जाएगा, यही तुम्हारा प्रॉब्लम है. यू हैव टू सॉल्व इट. अभी तक जो नॉलेज गेन किए हैं, विद द हेल्प ऑफ दैट यू हैव टू सॉल्व दिस टाइप ऑफ प्रॉब्लम. यहाँ पर शॉर्टेज आ गया है, ऑर्डरिंग इज इंस्टेंटेनियस, कितने का ऑर्डर कर रहे हैं वो भी इज गिवन. द डिमांड इज डी पर डे. यहाँ पीरियड एक साल का नहीं लिया गया, ओनली 1 डे का. द पीरियड इज रिलेटिव, इट मे बी 1 day, it may be 1 week, 1 month, 1 year, like that. So in this problem, the demand is given 200 units per day. तो सारा कॉस्ट को भी तुमको सेम यूनिट में लाना है, दैट इज पर डे. यू हैव टू कन्वर्ट ऑल द कॉस्ट पर डे ओनली, जहाँ टाइम की बात है. लेकिन CS में कोई टाइम का बात नहीं है, दैट इज पर ऑर्डर ओनली. द ऑर्डरिंग कॉस्ट इज ₹50 पर ऑर्डर, इसलिए कोई टाइम का बात नहीं है, एज इट इज CS. बट C1 देखो ₹2 पर यूनिट पर डे ऑलरेडी दिया हुआ है पर डे. अगर ये पर एनम रहता, देन यू हैव टू डिवाइड दिस बाय 365, इसको डे में लाना पड़ता. इज इट क्लियर? अच्छा, ये भी जो है कोइंसिडेंस इस प्रॉब्लम में पर डे ही दिया हुआ है, दैट इज C2 इज द शॉर्टेज कॉस्ट, ₹10 पर डे पर यूनिट पर डे, ये शॉर्टेज कॉस्ट है, ये भी पर डे में दिया हुआ है. अगर ये साल भर का दिया रहता ₹10 पर यूनिट पर एनम, तो उसको डे में कन्वर्ट करना पड़ता, देन यू शुड प्रोसीड. जब भी प्रॉब्लम डील करोगे, यू चेक इट, तो सारा यूनिट सेम होना चाहिए. एक डे, एक मंथ, एक ईयर नाम ऐसा होने से नहीं चलेगा. ये कंफ्यूज करने के लिए कभी कभी एग्जाम में इस तरह से दिया जाता है. देन यू कन्वर्ट टू एनी सिंगल टाइप ऑफ यूनिट्स. अगर तुम सबको ईयर में ले जाओगे, देन देयर इज नो इशू, तुम्हारा आंसर ठीक आएगा. अगर डिमांड को इसको मल्टीप्लाई करे तो 365, इसको भी C1 को भी 365 से मल्टीप्लाई, यू कैन चेक इट करके, तब देखोगे रिजल्ट एक ही आ रहा है. ओके, नाउ Q0 ऑप्टिमम ऑर्डरिंग क्वांटिटी निकालना है. तो फॉर्मूला चेक कर लोगे, यही फॉर्मूला है, ऑलरेडी मैंने मेंशन किया, जो डिराइव किया इतना मेहनत करके, तो ये लिखा गया. डी डिमांड है, ये ऑर्डरिंग कॉस्ट है, ये जो है तुम्हारा कैरिंग कॉस्ट है, और ये शॉर्टेज कॉस्ट है. वही 2 डिमांड, ये ऑर्डरिंग कॉस्ट, ये कैरिंग कॉस्ट और ये शॉर्टेज कॉस्ट. ये 109.5 यूनिट्स, ये ऑप्टिमम ऑर्डर क्वांटिटी है. एक बार में 109.5 यूनिट्स को ऑर्डर करना है. ये बार साइकिल, ये जो साइकिल था, टाइम पीरियड, ये जो टाइम पीरियड, टोटल टाइम पीरियड, एक टी का वैल्यू क्या हो जाएगा, एक साइकिल का टी, व्हाट विल बी द वैल्यू ऑफ टी. तो टी इज Q0 by D. Q0 by D, Q का वैल्यू ये ऑलरेडी निकल गया, एंड D इज दिस, दैट इज हाफ डे. सर ये कैसे आया, यू कैन डू इट सेपरेटली ऑल्सो. पहले नंबर ऑफ ऑर्डर्स निकालोगे, यू डू इट योरसेल्फ, मैं नहीं दिखा रहा है. और नंबर ऑफ ऑर्डर्स कितना हो जाएगा, D by Q0, और एक साल का बात है, टोटल टाइम पीरियड निकालने के लिए साल का, तो 1 डिवाइडेड बाई Q/0, तो Q0 by D हो जाएगा. यू कैन कैलकुलेट हाफ डे. दिस शोज दैट द ऑप्टिमम ऑर्डर क्वांटिटी of these units must be supplied after half day. हर हाफ डे का बाद ये सप्लाई करना है. नाउ दिस लास्ट पार्ट, इफ द पेनल्टी कॉस्ट बिकम्स इन्फिनिटी, तब क्या हो जाएगा. अगर पेनल्टी कॉस्ट इन्फिनिटी हो जाता है, तो दिस पार्ट विल वैनिश, ये 1 हो जाएगा. infinity, this divided, this will be 1. And that means the formula will be changed to this type, 2 into this part, 2 dcs divided by c1 only. तो ये करते तो ऑप्टिमम ऑर्डर की क्वांटिटी 100 हो जाएगा इसमें हमें 109.5 नहीं, ये हो जाएगा। इसका मतलब 100 करके ऑर्डर करना है। और टाइम इंटरवल प्योरली हाफ डेज, यहाँ पर देखोगे दोनों हाफ डे बाद में ही इसको ऑर्डर प्लेस करना है। 100 डिवाइड बाई 200, इसमें थोड़ा सा ज़्यादा था, 109.5 बाई 200, इसमें तो मैंने राउंडिंग कर दिया तो हाफ डे पर होगा। तो इसी तरह से यू कैन सॉल्व द प्रॉब्लम ऑफ इकोनॉमिक ऑर्डर क्वांटिटी with shortage. Okay, if you have any problem, any doubt, then definitely write to the comment box and I will answer it at the earliest possible. तो ये रहा डिटेल्स कैलकुलेशन। एक बार मैंने केवल जस्ट फॉर यू, अगर कोई क्वेश्चन छूट रहा है, नहीं दिख रहा है, तो फॉर दैट पर्पस इट इज बीइंग shown here, it is being shown here, this part you can check it, all the question, this is the calculation. And the first part, again I am showing you the first part of the calculation. Again I am showing you, if any part is left out, then check it. First, these are the assumptions and these are graphical presentations, and then few basic formulas which are used to derive this. So that is all about, and this is the total minimum cost, the formula for total minimum cost. So check it, it's the total minimum cost. Okay, तो आज इसी तक इकोनॉमिक ऑर्डर क्वांटिटी with shortage, and next I will discuss the revised और इकोनॉमिक ऑर्डर क्वांटिटी अंडर लिमिटेशन। ये मेरा नेक्स्ट वीडियो रहेगा। तब तक के लिए थैंक यू वेरी मच।